Namaskar friends, we will solve some examples which will be to your interest and which will clarify many of the concepts of the plastic analysis. First, I will conclude that what is the methodology of plastic analysis. First, we draw the structure and visualize the different types of mechanisms possible in this structure. So, what we have to visualize that at which critical points plastic hinges will be formed and it will become the structure will become a mechanism. So, we will go on visualizing alternative mechanisms putting plastic hinges at various places, various critical places where it is required, and we will make the various alternative mechanisms, and for each mechanism then we will calculate the critical load. How we calculate the critical load? For a mechanism we give a virtual displacement according to the mechanism, and then we calculate the external virtual work done and internal virtual work done, and we equate both the terms and we calculate the critical load. After calculating critical load for all the mechanisms, we compare, and the mechanism which gives the least value of critical load becomes the critical mechanism. On the basis of that mechanism, we calculate the moment at other joints where plastic hinges has not been formed. So, in this way we draw the bending moment diagram and analyze the structure. Friends, let us take an example to clarify these concepts. So, friends, let us take an example of a frame where the loading pattern, let us take it P and let us take it 3P. Let us take MP and MP for the columns, and the value of plastic moment equal to 2 MP for the beam. So, this is our structure, and the length of the beam is L, and let us take this also as L. So, let us visualize what will be the type of mechanisms in this structure. So, the first one, let us take the beam mechanism. So, what will happen in the beam mechanism? In the beam mechanism, the hinge will be first formed at the joints with a little change here. Since the value of plastic moment is 2 MP in the beam BC and MP is in the column AB and MP is column CD. So, what will happen that instead of being hinge formed here, the hinge will be formed in the column, just at the tip of the column, because the value of plastic moment is lesser in the column AB. And again in the case of column CD, the hinge at this joint will be formed just at the tip of the column CD, so that the value of moment will be instead of 2 MP, it will be equal to MP at both these places. So, naturally the structure which is weak, that will undergo in the process of plastic area. So, the plastic hinge will be formed in the columns, and the value of plastic moment we will take here at MP. But in the middle, again after that plastic hinge will be formed in the middle, and there is no other option but go for the 2 MP. So, here the value of plastic moment will be equal to 2 MP, and the mechanism will be like this. So, if this angle is theta, this angle also will be equal to theta, and this angle will be equal to 2 theta. So, let us calculate the value of external virtual work done and internal virtual work done in this case. So, external virtual work done will be equal to 3p is the load, because this load is undergoing displacement through this distance, and this distance will be equal to L theta by 2. Since this distance is L by 2, so this distance will be equal to L theta by 2. So, 3p, let us call it PC1 critical load for mechanism 1 multiplied by L theta by 2. Since there is no displacement in this direction, so the load P will not be doing any virtual work. This will be equal to the internal virtual work done, and that will be equal to MP multiplied by theta at this place, because here the rotation will take place in the column, here also rotation will take place in the column because of the lesser value of plastic moment. So, this will be equal to theta plus theta plus there is rotation of 2 theta in the middle, and the value of plastic moment is 2 mp. So, it will be equal to 2 mp multiplied by 2 theta. So, the equation becomes 3 PC1 L by 2 equal to, this is 2 mp theta and this is 4 mp theta. So, it becomes 6 mp, and theta will be cancelled from both the sides. So, this will give the value of PC1, and that is equal to 6 into 2 by 3, that will be equal to 4 mp divided by L. So, this is the value of critical load that comes out in the first mechanism. Let us take the second mechanism. The second mechanism, let us call it sway mechanism. In sway mechanism, the hinges are formed at all the 4 joints, and the structures fall down because of the lateral load. So, this is our structure, and the hinges are formed at all the 4 points A, B, C and D. So, here, here, here and here. The only caution we have to take, that since the value of MP is twice MP, plastic moment is twice MP for the beam and MP for the columns. So, at the joints where the beam and column is meeting, the plastic hinges will be formed in the columns. So, in this case, suppose if we give the rotation theta to the mechanism because of this lateral load P, say PC2, and again this lateral load, this vertical load is 3 PC2. So, this angle will also be equal to theta. Now, let us calculate the external work done, virtual external work done, and that will be equal to PC2 multiplied by L theta. Since this angle is theta, and this distance is L. So, this distance will be equal to L theta. So, the external work done will be equal to PC2 multiplied by L theta. This vertical load will not be doing any virtual work because there is no deflection in this direction, and this will be equal to the internal work done, that will be equal to MP multiplied by at all the 4 rotations, because all the 4 rotations are taking place in the column, and the value of rotation is equal to theta at all the 4 places. Here also theta and here also it is theta. So, value of rotation is theta. So, the value of internal virtual work done, virtual work will be equal to MP into 4 theta. So, this will give the value of PC2, the critical load in mechanism 2, and that is equal to 4 MP by L. So, if you compare from the first one, again in the case of first one and in the case of second one sway mechanism, the value of the critical load is coming out to be same. Now, let us take mechanism 3. So, for third mechanism, this is a combined mechanism and this is combination of the first two, that is beam mechanism and sway mechanism. So, in this case the hinges, plastic hinges are so formed that partly the structure undergoes sway and partly the beam failure is done. So, suppose this is our structure and the hinges are formed at this place at A, there is no hinge formed at this place, and in the middle there is a hinge is formed, and again here at this joint C, since the value of plastic moment is 2 MP for BC. So, hinge will be formed in the CD. So, here another hinge is formed at this place at point D, hinge is formed, and if we give rotation theta to the mechanism, say this angle is theta, there will not be any rotation at this point because no hinge is there. So, a 90-degree angle is made here, and again this point will also undergo a rotation of angle theta because these are two parallel limbs, and here hinge will be formed and this angle will be equal to theta, this angle will also be equal to theta, and here the rotation of this limb, if we take effectively if we take perpendicular here, this angle will become 2 theta because theta on this side and theta on this side will make effective rotation at 2 theta at this joint. So, now let us calculate the value of critical load for this mechanism. So, here the load is PC3 and the vertical load is load is 3 PC3. So, what will be the virtual external work done? That will be equal to PC3 multiplied by this distance is L theta. So, this is L theta plus this vertical load is also undergoing a displacement of this much distance, and this distance is equal to L theta by 2. Since this distance is L by 2 and this rotates by angle theta, the complete joint is rotating, there is no deformation at this joint, the angle is maintained at 90-degree, but since this angle is theta, so this distance will be equal to L theta by 2, L by 2 multiplied by theta. So, it will be equal to 3 PC3 multiplied by L theta by 2, and this should be equal to the internal virtual work done, and that is equal to MP multiplied by theta at this place, again MP multiplied by theta at this place, and MP multiplied by 2 theta at this place. So, it will become MP theta plus 2 theta. In the middle, the value of MP is equal to 2 MP, the value of plastic moment is equal to 2 MP. So, here the internal work done will be equal to 2 MP multiplied by rotation here, that is equal to 2 theta at this point, this angle will be equal to 2 theta. So, MP multiplied by 2 theta. So, now let us calculate the value of PC3 from this equation. So, if we take, it will become 5 PC3 by 2 will be equal to here 4 MP, and this is equal to 2 plus 2 4, 8 MP. So 8 MP by L, or PC3 will be equal to 16 by 5 MP by L. So let us compare, friends. In the earlier two case, let us see what is the value of critical load has come. In both the cases, PC1 and PC2, the critical load is 4 MP by L, and in this case PC1 and PC2, that is critical load in the mechanism 1 and mechanism 2, it is coming out to be 4 MP by L, and critical load in the third mechanism, it is coming out to be 16 by 5. So this is the lowest value of the critical load. So this is our real critical load, and this is our real critical mechanism, that is the combined mechanism which we have taken. So on this basis we will calculate the values of moment. So friends, let us draw the structure again. This is our structure, and you can see a hinge has been formed here, a hinge has been formed here, a hinge has been formed here, and hinge has been formed here. So the value of moment at this place will be equal to MP. Again the value of moment at this place will be equal to twice MP, because the plastic moment of the beam is twice MP. The value of moment at joint C will be equal to MP, and the value of moment at point D will also be equal to MP. The only point which remains here to be calculated, that the value of moment at point B. So let us see using the simple statics how we are going to calculate that value. Let us draw the free body diagram of the structure. We have cut at this point just above A and D. There is load PC3 at this point and 3 PC3 at this point. So there will be a horizontal load HA at this point and HD at this point, and the value of moment is MP at this point, and again the value of moment is MP at this point. So if we write the equation in the horizontal direction, equilibrium equation, so HA plus HD will be equal to PC3. HA plus HD will be equal to PC3 in the horizontal direction. Again, for calculating the value of HD, why we are doing this? Because we have to know the value of HA. To calculate the value of moment at B, we have to consider the free body diagram of column AB, and for which we will require the value of horizontal force at A. So before doing this, we are calculating the value of HA, and we have cut at these two places. You can there can be many ways of calculating the value of HA. We are just taking here a method in which we have cut both the columns here at these places, and this equation has come out to be like this. Again, if we take the free body diagram of the limb CD, this is column CD. So here the value of moment is MP, and the value of horizontal force HD is also there. There will be vertical reactions also, VD and VA, but this is not important here, since we are not going to use these values. Only we are writing equation in the horizontal direction. So these values are important. So if we take moment here also, Vd will be there. So if we take moment around point C, the value of moment at point C also, as we know from the earlier analysis, that here the value of moment is mp, and this is going to deflect in this fashion. So the moment will be in this direction. So here the moment in this direction mp will be there. So here if we take moment about point C, so mc plus 2 mp, mp at this point and mp at this point, sorry, mc is known to us, so that is equal to mp. So if we take moment about point C, the value of moment will be mp plus mp, twice mp, that will be equal to hd multiplied by this distance, that is L. So hd multiplied by L. Here the vertical reaction will not come into the picture, because we are taking moment about point C, and the horizontal and vertical reaction at point C are also not coming into the picture, because since we are taking the moment about point C, so all these values will be equal to 0. So from here we can calculate the value of hd. Value of hd will be equal to twice mp by L. So from here you can calculate the value of HA, since HA plus HD is equal to PC3. So HA will be equal to twice PC3 multiplied PC3 minus HD, that is equal to twice MP by L. So friends, this is the value of HA we have calculated. The value of PC3 is 16 by 5 MP by L minus twice MP by L. So this will be equal to 6 MP by 5L. Now let us take the free body diagram of this BA, column BA. So what are the forces coming at the ends? Here the value of HA is now known. So this will be HA, again VA of course will be there, and the moment, value of moment here is MP. Here the value of moment is not known, let us take it MB, unknown MB, and if we take moment about point B, then the what will be the equation? MB plus MP, MP at this point, that will be equal to HA multiplied by L, HA multiplied by L. So MB will be equal to HA multiplied by L, that is equal to 6 by 5 MP. From this equation, HA multiplied by L will be equal to 6 MP by 5, minus this MP will come here, minus MP. So from here we can calculate the value of MB will be equal to MP by 5. Okay. So you can see friends that the value of MP, value at point B, that is the moment at point B, has come out to be less than the value of MP. So this is the check we have to maintain. So again we will draw the bending moment diagram for this structure. Let us draw the bending moment diagram for this structure. So, the MP was here if we draw it on the tension side. So, here the value was MP and here MP by 5. This value is MP by 5, this is MP, and here the value is in the middle, it is equal to twice MP, and here the value is MP, here the value is also MP. So, this will be our bending moment diagram. So, this will be our bending moment diagram, friends, and you can see that at point B the value of moment is coming out to be MP by 5, which is less than MP. So, this is the check we have to maintain, that for the true mechanism or the critical mechanism, the value of moment at other joints where plastic hinge has not been formed, the value will be less than the value of plastic moment in the members. So, this check we have to maintain. Now, we will take another example. Friends, we will take another example where multiple bays are there and a frame in which multiple bays are there. So, how we are going to see the different types of mechanism possible in a structure. So, let us take all the lengths L and take load in the middle, say this is P, and let us take here also P and a load here P, and let us take different MPs, plastic moment MP at all the 3 columns, and for these beams let us take the value 3 MP. So, what are the possible type of mechanism? Very quickly we will see the first one. The first two you can visualize that beam failure in this beam and in this beam. So, both will be different mechanisms. So, let us say mechanism 1 where beam failure takes place in this one. If you give the nomenclature A, B, C, D, E and F. Okay. So, in panel BC the beam mechanism is there. So, this will be the mechanism and this angle is theta and this will be equal to 2 theta. So, if you very quickly if we write our the first virtual work equation, the virtual work done, external virtual work done will be equal to PC1 multiplied by L theta by 2, that will be equal to MP multiplied by theta. Now, this is important here. This hinge will be formed in this at the tip of the column AB because the value of plastic moment is MP and the value of plastic moment in the beam is thrice MP, 3 times more than the value of plastic moment in the column. So, the hinge will be formed here, but what will happen at this place, since here if the hinge is formed in the column, this will not be a failure, beam failure, because this is not going to rotate from this point, because this line will be straight, this beam will be straight, and if hinge is not formed in the beam, this mechanism is not, beam mechanism is not going to happen. So, the plastic hinge has to be formed in the beam only at this place. Here the plastic hinge cannot be formed in the column. So, the hinge will be formed here, and again of course, in the middle there will be a plastic hinge. So, the value of internal work done will be m p theta at this place plus thrice m p, this is 2 theta and this is theta. So, 2 theta plus theta, this will be the equation. So, this will be equal to m p theta and 9 m p theta. So, this will become 10 m p theta. So, P C 1 will be equal to 20 m p by L. Again we go for mechanism in beam 2, beam mechanism in this one. So, this will be like this, and the equation for this, for mechanism 2, will be equal to P C 2 into L theta by 2, because everything is same. So, the same results will come out. Let us see here, in this beam the hinge will be formed in this column, and again the hinge cannot be formed in this column. So, the hinge has to be formed here, and the value of plastic moment is 3 m p for this beam also. So, the same result is going to be come out. So, we need not consider both the mechanism, one mechanism is sufficient, because the critical value of load is coming out to be same. Let us take the sway mechanism. The sway mechanism, the hinge will be formed at this place, at this place, at this place, of course in columns, because the value of plastic moment is lesser in the columns. So, at all these 6 places the hinge will be formed, and the virtual work will be done only by the lateral load, because there is no vertical displacement. So, in this case external virtual work done will be equal to, say, if theta, it rotates by theta angle, the shape of the structure will be like this, and this is angle theta, again this is also angle theta, all the angles will be theta here in this case, theta. So, the external work done will be equal to P C 3 multiplied by L theta will be equal to m p multiplied by 1, 2, 3, 4, 5, 6 theta. So, this gives the value of P C 3 is equal to 6 m p by L. So, if we compare the value from the first two mechanisms, that is 20 m p by L, this sway mechanism seems to be lower value. So, this is 6 m p by L will be more critical than the first one. Now, let us see the combined mechanism. So, what types of combined mechanism we are going to take, friends? Since this is our structure, I will discuss in another few minutes what type of mechanism. In the similar fashion, combined mechanisms you are going to consider, that is combined with the sway and beam. Let us take a failure here and leave this place. A hinge is formed here, again hinge is formed here, hinge is formed here. So, this will become a combined mechanism, and for this combined mechanism, again this has to be taken in the beam and column both, because otherwise it will not go undergo any rotation. Let us see if we give a theta rotation here. So, this will become theta, again there will be angle here, there will be rotation at this place, and it has to. So, you can see that the rotation has to take place in this beam, because there is an angle in both the beams. So, it cannot be it is not possible by taking hinge in the column. So, the hinge has to be formed at the joint, so that the rotation of this beam and this column, both the beams are possible. So, in this case 3 MP will be taken for calculating the internal virtual work done. Friends, similarly we can as you have seen in the last example, that was a little complex frame where 2 bays were there. Various other mechanisms are also possible, and you have to consider all possible mechanisms where critical load should be considered, and go on taking the various different possible mechanisms and calculate the critical load, and whichever gives the least of all the critical loads, that becomes your critical mechanism. And your checkpoint, as I have told earlier, that your checkpoint is that for at any other place in the structure, the value of moment should not come more than the value of the plastic moment. So, friends, this is our checkpoint, and accordingly we see that we find out which is our critical mechanism, and for that we draw the bending moment diagram of the structures. Thank you very much.